Welcome to the MS Dev Show, episode number 173. This week we talk with Jennifer Marsman about using machine learning to build a lie detector and other cool ML projects. LinkedIn helps you write your resume. And a free chaos engineering book.
This episode of the MS Dev Show is brought to you by Expose, the market leader of .NET and Java APIs for file business formats. Natively work with DocX, XSLX, PPT, PDF, MSG, MPP, image formats, and many more. Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications. Check it out today at raygun.com.
This week we have Jennifer Marsman. She's a principal software development engineer in Microsoft's commercial software engineering group with a focus in data science, machine learning, and artificial intelligence. She has been featured in Bloomberg for her work using EEG and machine learning to perform lie detection. In 2009, Jennifer was chosen as techie whose innovation will have the biggest impact by Xology for her work with Give Camps. How's it going, Jennifer?
Very good. Thank you for having me.
Yeah, your intro, like you sent me this like really long version, and sometimes people do that and it's all like fluff, but like you had all real things in there. So I feel bad cutting it down because it was just amazing. So
people don't really need to hear all of it. It's not that interesting, really.
You've done amazing work though. I'll just keep that summary in there. And Carl, what do you want to talk about?
So we've had a few requests. So we have a Slack channel where you can come and talk to us any time of the day or night. We've been given a little bit of information that we have not been inviting enough people. So here's your reminder. You can sign up for this at slack.msdevshow.com, and that will get you to the Slack channel at msdevshow.slack.com. So sign up today. You can send yourself an invite. And also a reminder, we have the amazing Raygun contest. So let us know what your biggest programming fail or the worst bug that you've seen in code. Just a reminder, you can anonymize everything. We just got a pretty amazing story that came in. He said, please anonymize this, but he gave us the full details in an email. So yeah, don't be afraid. We do not want to get anybody in trouble. We just want to give away the 1-year full license for Raygun, as well as the 3 t-shirt and swag gift boxes that they will be giving out to the 3 runners up. Yeah.
And we already did have a question about like, can I pick something, if I win, can I pick like the swag box, if I already have Raygun? And I don't know, I haven't asked Raygun, but sure. Yeah, you can do that. Why not? So, you have some options. I think what we'll do is whoever is first, we'll kind of go down the list and they'll get priority in if they want the swag box or the license. Okay. So let's move on to the comment of the week.
So this week, the comment of the week gets a developer small business license for Expose.total for .NET, which includes all of the Expose.NET products in one package. And we got our comment this week off of Twitter from Dan Barkwell. 2 episodes ago, when we were talking to Ryan Nowak, I had mentioned that I do use a dial when developing, and he wanted to know how I use it for developing. So by default, a dial can scroll and it gives really nice fine-grained precision. So if you have like a big file or something, it's easy to either like spin through it real fast or go through it with a lot of control. But in addition, there is a Visual Studio extension by Nico Vermeer, Microsoft MVP, who will, when you're debugging, let you step through your code. And the one thing that's really cool is with Visual Studio 15.5, you can go backwards now. So I'm waiting for him to update that extension so I can go forward and backward in my code with my dial.
So you'll be like, that'll be awesome. It's a time machine dial.
Yeah. And if you want to get mentioned on the show like Dan did, send us an email to feedback@msdevshow.com, comment on Facebook, YouTube, or Stitcher. We really like those 5-star iTunes reviews. And if we do get pick something that doesn't have an email address on it, please send me your email address afterwards if you're a winner. I need those to give to Expose to get you your license. So if you've won in like the last 4 or 5 weeks, I need your email address.
Oh, and just to close out the contest that we mentioned earlier through Raygun, so the deadline is going to be December 1st. So make sure you don't procrastinate. Get those in as soon as possible. Okay, so let's jump into the news. So let's see, what do we got here? Microsoft integrates LinkedIn with Word to help you write a resume. This is pretty cool.
I think this is just makes a lot of sense. The last two jobs that I've applied for, I actually didn't even have my resume. I said, well, I did have a resume, but first I said, here's just my LinkedIn. It has all my information. It has all my previous employers. It has my experience. It has all the stuff that I'm going to put on a resume anyways, except for my contacts. But
No.
we don't need those.
Yeah.
So I think this is really cool. It's just one way for you to automate and get half that stuff imported into what you're gonna have to do anyways.
Yeah.
And with the other technologies, I don't know if Word has this, but on PowerPoint you can write a slide and it says like make this better. I can't wait for Word to do that with Resume with this. So it's pretty much
That'd
you
be
import
cool.
it and you just make it better and you're just like, all right,
Yeah.
there, I'm done.
So what's cool about this too, you can put in your role in industry, and I mean, you could, this thing doesn't do anything that you really couldn't do before, but what it'll do is it'll go out and fetch some impactful statements for you that you could potentially use as inspiration. I never recommend anybody lie on their resume. I hope that this doesn't lead to people being like, I didn't grow the business by $50 million, but that sounds cool. So they're like adding it in. So I'm hoping that doesn't happen. But being able to sort of look at those impactful statements and figure out how to word your resume could be really useful. Cause we had an entire episode on this and people are they're just terrible. Even if they're like great at what they do, a lot of times they're just terrible at conveying that on a resume. And it's really a shame because they're missing out.
Yeah. I think the other thing is that once you've been in the industry for a while, like you forget, like the people that you worked with, 3 jobs ago and kind of the stuff that you did. So that makes it really nice to just like, as long as if I keep it all up to date in LinkedIn, then bam, I'm done and I'm good.
Yeah.
And I can just dump it to a resume at any point. That's really cool.
Yeah. LinkedIn has been my system of record.
Yeah. And I love just like from the machine learning aspect of it, that is really cool. There's actually a company called Texio, and it was started by 2 former Microsoft employees actually. And what they do, it's kind of the opposite side of the coin, but instead of helping people write resumes, they are helping people with job descriptions in order to try to make it more to get more people to apply for jobs. So they use machine learning, and they actually record like who clicks on which links, like that sort of thing, and who applies for what jobs, and then analyzes the text in there to see, what jobs are attracting more people. Because there's words that fall in and out of favor. Like a couple of years ago, like big data was the thing, and every company was saying, "Oh, we do big data," until it got like so, and those were more likely to get for people to apply for them. But then over time, it kind of became passé, and then nobody uses it anymore. So just being able to update models like that on the fly. And then the other thing that's cool is they also do some stuff for gender balancing. Like they keep track of females and males click on these, and if you use different language, they say that helps show get more female applicants or male applicants. If you're in a situation like nursing where there's fewer males, or technology where there's fewer females, and you want to try to attract the opposite gender. So really interesting stuff.
Yeah, that's actually a great tip because I'm already aware of certain language, but like how do you actually apply it? So that's pretty cool that it analyzes and gives you that feedback. That's great.
Yeah.
Very cool.
Texio.com. Yeah.
Okay. We'll have a link to that in the show notes.
Yeah. Yeah.
And then does the brain interact with programming languages like it does with natural languages? I've always kind of wondered this.
Well, if we click into the link from Reddit here, it's really just a question that starts off a Reddit discussion. And there is a little bit of backing studies that have been done, but I just kind of toss this in here as kind of a little exercise, because I know throughout the years as I've become more adept at development, that there's certain languages I really don't have to think, as I want to get something done. The code just kind of appears and then out of my fingertips to the keyboard. Whereas when I'm in other technologies that I might be a little bit newer with, I definitely have to think about the structure and syntax. And, I also kind of equate that, or I'm going to get, I'm not going to get the details of this right, but there's in the English language, if you have adjectives, I think it's adjectives, maybe adverbs, but there's a certain order, like, there's color and, blah, blah, blah. If you get those out of order, like, it doesn't make sense. And everybody always just intuitively gets them right in order. So I just think that once you get to a certain level of adeptness, that your brain probably processes code very similarly.
Yeah. And it adapts. Absolutely. I mean, I was having dreams last night about Docker. So, I mean, there's no there's no doubt of like the effect on your brain. And it's interesting because they do have some evidence in here about like MRI scans and how it is similar to, in some cases, how language is processed. But, I think this also falls into this thing where they say, what is it, 10,000 hours or they say 10 years, to become an expert in something. And I think that's at the point where your brain has sort of rewritten itself enough to, to be optimized for the thing that you're doing. And that's what's going on here. I don't know a second language, spoken language. And, what always amazes me is whenever I'm speaking to somebody who their first language is not English, I can tell that they're thinking in English, when they're talking to me, because at the rate, you're asking questions, they're giving immediate responses. Whereas, languages that I've started learning, I had Spanish in school, and in my head, I'm always kind of like, okay, here's what I want to say. How do I translate it? And I think the same thing probably happens with programming languages too. Like, here's what I'm trying to do. How do I translate that into code? And then eventually your brain kind of gets to this point where whenever you see a problem, you sort of visualize the answer in not necessarily in code, but in maybe encoding patterns. I don't know. I'm not an expert on this, but
yeah, it's fascinating to think about. And when you look at, so I wasn't able to read the article prior to this discussion, but when you think about just what artificial intelligence has done and some of the programming constructs that we have there, like the whole idea behind neural nets too was to try to map, the way that brain processes things, and use that for machine learning as well. So it's in some work that I did when I was much younger, actually. It was at a company called Soar Technology, and they also had a programming language that was trying to, map to the brain a little bit more effectively. So it is really fascinating, the ways that you can talk about like the brain and programming together.
Cool. Okay, running Node.js and the Windows subsystem for Linux from Visual Studio Code. What?
So I found this article really interesting because I had just gotten a question from somebody recently. Is Windows Subsystem for Linux ready to like run production code on? And like a week after I got that question, we see this here is from Visual Studio Code, you can execute your application directly on the WSL, which I think is really interesting. So it doesn't really answer the other question, but I just think I love how those things are associated. When you start talking about technology, all of a sudden it just pops up everywhere. Also, if we look at the comments for this, somebody's like, well, what about Rails? Well, will Rails run on WSL? And I love the answers. Try it and let us know.
Yeah. Well, because they're operating at a totally different level, right? They're adding in the APIs. It's getting shockingly complete. It's, I don't know. It's just super interesting at like how good it is. And then as they implement these APIs, they're just opening up all these scenarios that they can't even really think of.
Yeah, and the fact that it's no longer a developer hidden behind a developer flag, they're enabled by default. It's going to be really interesting to see where this technology goes in the next release or two of Windows.
So speaking of cool stuff in VS Code, I'm going to add a surprise article in here. Actually, it's not even an article. It's just a feature. So in VS Code, in the latest update for VS Code, there is a cloud shell now for Azure integrated in. So in VS Code, if you're not familiar with it, you can have like the terminal and console and PowerShell, and you can have all these different tabs at the bottom. Now you can have a cloud shell, which is kind of mind blowing because it saves your context, right? So you can. You're actually running command lines like in Linux, like on this other machine. And it's kind of neat because you can provision some Azure services, for example, from that cloud command line. Then you can go on a different computer and like keep working there. And you don't even have to install the tools, nothing. Like as long as you have VS Code on there, like you can be using this command line, which is like sort of hard to wrap your mind around that you're in a local machine, like sort of remoted to this other machine running these commands that are affecting this cloud infrastructure. And it's just so cool.
That's really awesome.
Yeah.
I'm a big fan of the Visual Studio Code tools for AI that were released just at Ignite last year, or a couple months ago, actually, not that long ago.
It's like tools for everything now.
Yeah, it's great.
But they're the ones for AI are pretty good.
Yeah, you can use them to like submit a job. So if you're writing some Python or such on your machine, you can then just use them to be able to submit the job right up to the cloud and be able to run it, in GPUs or, in a Docker container, basically anywhere. So they're really nice. Yeah.
Yeah, it's cool how it detects now too, like what you're doing. I was doing some Docker stuff the past couple days, and it pops up. It's like, hey, we got a Docker extension in here. Okay, install. And then all of a sudden I was getting IntelliSense for Docker. I'm just like, wow, that is such an awesome experience.
Nice.
I didn't have to because otherwise I wouldn't have realized that there was an extension. And if I did, I'd be like, where do I go get extensions again? And it was just like, hey, we can make your life better. Do you want us to? Yes or no? And why would you pick no? And the last one in your chaos engineering book, what's this about, Carl?
Yeah, so a few months ago, we had Charles Torrey on to talk about chaos engineering, and I thought that it would be a great just callback to a previous episode. Actually, both of us, Jason, we were talking with Charles Torrey yesterday, and he let us know that he has a book on O'Reilly that's available for free. So go to the show notes and click on that link, and it'll take you to O'Reilly where you can put in your email address and get his book. So if you want to learn more about chaos engineering, go there. If you want to remember what we talked about last time, hit our backlog.
Okay. It'd be funny if this page, would give random errors and the URL would change. And anyway, awesome. Okay. So that's all we had for the news. So let's get over and talk to Jennifer, because she's been working on some really cool stuff that's kind of mind blowing or mind reading, however you want to say it. So, so I guess, we've had an episode, actually, I think a couple episodes on machine learning, but it's such a huge field, and people, the possibilities in my mind are so endless. From stock trading to self-driving cars to you're actually reading minds with it. It's just this huge thing that's sort of taking over the world very quickly right now. So, this is just great timing for an episode. So I guess the first thing I want to ask, to you, how do you define machine learning? And then are there different kinds of machine learning?
Yes, there are. Okay. So, if it's the very tough question of the difference between machine learning, predictive analytics, statistics, and artificial intelligence, you will not even get a straight answer for that from even experts in the community are still arguing about where the lines are drawn between those things. So that's a kind of a tough one, because whatever answer I give, somebody's going to be mad and say, no, that's not quite right. But let me start by telling you about the different types of machine learning, and then we can go from there. But there's kind of maybe three major categories of machine learning. There is unsupervised machine learning, wherein you have a set of data and then you're able to do things. Well, actually, let me talk about supervised first, because then you'll understand unsupervised a little better. There's supervised machine learning, and with supervised machine learning, essentially you have you can use that to do predictive analytics type work. So let's say I wanted to predict the cost of a home. What I would need is a whole bunch of data with historical values of the cost of homes. So I would need both how much these homes cost, as well as, and that's what's called my label field, and then a whole bunch of things that affect the cost of a home. So maybe the number of bedrooms, the number of bathrooms, the zip code, because location or something can make a big difference, the number of years since the kitchen's been remodeled, or the size of the master bath, because in the Midwest, we love our huge master bathrooms. Just things like that, that would affect the cost of a home potentially. Maybe this the rating of the school district, something like that. And so then once you have all that historical data, based on these features, it produced those labels, you can apply a supervised machine learning algorithm to that historical data. And essentially all that does is use crazy beautiful math to find the correlations between those features and that label. And so it really depends, the kind of algorithm you use affects the kind of math it is, and different algorithms are better based on a number of different factors, like if you want to be able to retrain it and kind of what the data looks like and if it can fit a linear model or not. So the algorithm that works best will vary based on the situation, but there's a lot of different algorithms that use different types of math. Yeah, sorry to cut you off, but do I still have to know the type of algorithm? Because to me that was always the biggest barrier
to machine learning. Cause it's like, okay, I get all of this and I go through and then it's like, hey, pick an algorithm. I'm like, what?
Okay. Well, one thing I have to mention then is there's a wonderful resource called the Azure Machine Learning Cheat Sheet.
Okay.
And I will give you a link to that because you can download it as a PDF and hang it in your office like all the cool kids do. But it's a really great thing that was put together by Brandon, who used to be on the Azure Machine Learning team, a data scientist there. And he put together essentially like the first version was a sort of a flow chart that kind of asked about, the number of features you have and the kind of tasks that you're doing and stuff like that. And then it kind of mapped you to the best algorithm to start with. So that's a great resource. If you don't know a ton, you can just try some of those things. And then the other thing is just thinking about, like, there's kind of different categories of learning, because you can think about modeling something like that with something as simple as like a linear regression type thing. So if you remember back in like high school math or whatever this was, maybe even middle school, like AX plus BY plus CZ, right? Where it's just a bunch of numbers with weights on them. And so if all of your data was numeric and you have things like the cost of the home or the number of bedrooms, number of bathrooms, and let's pretend those were all numbers, it may be something as simple as different factors have different weights to them. And it's just the machine learning algorithm just finds those weights that applies to, okay, here's how much the size of a bedroom seems to matter, and here's how much the size of the number of bathrooms matters, and that sort of thing. And that's one really, really simple way you can do it. But as you know, like, not all data is linear. And if you remember, just like, again, high school math, if linear type stuff can do a straight line, but if you want to be able to do things more complex, like more complex shapes to like map things, you need to get into higher order polynomials, right? So if you have your, if you want to do any kind of a curve like that, you need an x squared plus something, right? So you can model more complicated things with those higher order polynomials. But again, that's just, the math. But anyway, you don't really have to know any of that. So to back it up a little bit, how you could do it is, you could kind of think about it like, is this, linear, something that could be solved like linearly? And then if it's not, so with like neural nets and deep learning and some of the stuff we're doing too, those interact in a way that takes care of some of those problems. And then decision trees as well basically create a little flow chart under the covers that can map something that says, if I'm trying to predict who would survive and who would die on the Titanic when it sunk, a decision tree could model that fairly well, where it has a little node where it says, okay, was the person a female? Then yes, they're actually pretty likely to survive. Was it a male? Okay, how much did they pay for their ticket? And kind of break versed on first class passengers and third class. So you can actually model that using a decision tree with fairly high accuracy. And then there's some other things that are interesting too. When you think about like medical and predicting diseases and such, a lot of times you'll find that like the death rates, or the people who really are affected hardcore by some of these diseases, are both the very young, right? Babies are particularly susceptible to disease, and the very elderly tend to be very susceptible to disease. And then, regular, normal, healthy adults are kind of in the middle. So that's always going to be kind of modeled something like that. And you can't fit a straight line to that if you were trying to plot age versus, likelihood of death or something like that, or likelihood to catch a disease or something. So just thinking about things like that. But you start with the Azure Machine Learning cheat sheet. And then the thing that's nice about like the Machine Learning Studio, for example, is that they have like these 25 different algorithms, all as little modules, and you can very easily drag and drop one in and out to try different algorithms and see which one works the best for your particular data set. Okay. So that's another great way.
Raygun gives you... Hold on, scrap that. You've heard this ad way too much. Raygun is giving us an awesome chance to give away a free year's startup plan of Raygun crash reporting. In addition, 3 runners-up will win swag packs that include t-shirts and other freebies. You definitely want some of that. What do you have to do? That's a simple thing. Just let us know. What's the biggest programming fail you've ever seen? What's the nastiest bug you've ever caught? Let us know. Email us at feedback@msdevshow.com. Contest ends at the end of November. Hurry up and get it in now.
Okay.
Yeah.
Yeah, so as we continue our discussion and as we start looking into machine learning, what's the key vocabulary that we really need to know? I mean, we've talked about like models and training, but what do we need to know to really understand this?
And we didn't cover unsupervised yet.
Yes, I'm sorry. I was just thinking that I went off onto my tangent.
There's so much terminology.
There is so much terminology. So if you're doing supervised machine learning, it's good to know. I mean, some people use different things, but I use the term features for the things that predict. So the thing that you want to try to predict is called your label, your label field. And with supervised learning, you do need a labeled data set like that, where I have all this data, house data, and then the label of how much the house actually cost. So the cost would be the label, and then everything else that affects the cost of a home would be my features. So features and label are two key things with supervised machine learning, and good terms to know. And then the other unsupervised learning, you don't actually need a labeled data set to do unsupervised learning. With unsupervised learning, you can do things like clustering, which is great for things like recommendation engines. If you want to build here are things that are similar to each other, you can choose some kind of thing that relates them and figure out which things are similar along various axes and then group like things together, right? So clustering is great. Like if you're trying to recommend restaurants or recommend movies, you could see that, okay, I tend to like things with these characteristics, and other things that are close and have similar characteristics I'm probably going to like too. And then the other one is reinforcement learning. And when you look at all of the stuff that was done, like when Google's work with AlphaGo, their Go algorithm, that was a very big deal in the machine learning and artificial intelligence community, because Go is a very complex game where if you look at the tree of, with chess, it's there's a smaller number of possible moves at any given point. And with Go, the number is it's huge. It's very complex. And so that's why it was always stated that, this is something that, you would need real human intelligence to solve this, just because of the number of possibilities. And with what Google was doing with AlphaGo is something called reinforcement learning, and it's essentially almost like a turn-based type of learning where the algorithm gets a reward every time they do something that makes progress towards a goal, and so that way they kind of try to seek the rewards and then continue to learn by trying to get more points or more rewards, essentially.
Very cool.
So,
and other terminology is that
other terminology? Yes. So models are essentially the mathematical models that determine the relationships. In the case of supervised learning, the relationship between those features and that label. So with machine learning, there's if we're doing supervised machine learning, there's two phases to that, right? There's a training phase where I take all of that historical data and I apply the math, and that builds a model. The output of that is a model. And basically it's some kind of math that finds the relationship between the features and the label. And then there's a second phase, which is when you actually use the model. And that's, actually at runtime, you can then call that model, giving it only the features. Okay, so for a new house that it's never seen before, here's all this information about the house, and then the model will be able to use what it's learned and tell you, okay, here's what I predict how much that house will cost based on everything I've learned historically. So that's essentially what a model is.
Okay.
And I'm trying to think if there's anything else, any other big terminology. Models, the different types of machine learning. There's a lot of different algorithms within each of those categories, different ways to do supervised and unsupervised. But let me know if there's anything I say that I didn't explain well enough, and I can make sure I define anything as well.
Mm-hmm. No, and in fact, I'm as you're talking, I'm sitting here looking at that cheat sheet that you had mentioned before, and I find it really useful because it in the middle it just has start, and then it's like, what do you want to do? And there's only 4 or 5 things that you can do with machine learning, right?
Yeah, so Azure's machine learning doesn't actually include reinforcement learning yet. So that was those are the things that are currently in Azure Machine Learning, that the Azure Machine Learning Studio. And we have some additional tools that were just released at Ignite that go beyond that, even more so as well. So that's the Machine Learning Studio. The Machine Learning Studio is awesome if you're a developer and you're starting to get into data science, and maybe you don't know everything about machine learning yet, but that can give you enough to be really powerful powerful and to do some pretty cool stuff with, not having to understand all of the details. And honestly, most practitioners of machine learning, you have to understand the data science and how to do it. But we all use libraries too, right? There's a lot of great libraries out there. So you don't want to reinvent the wheel, much like you wouldn't, write your own square root function as a developer, even though you probably could. You're a smart guy, but why would you? Because there's libraries that do that for you. So it's the same thing with machine learning. There's a lot of great, well-known algorithms and Python libraries and stuff in R as well. And everyone pretty much just uses those if you're a practitioner.
So speaking of being a practitioner of machine learning, you have built something to tell if somebody is lying. I thought that was really cool. So I was hoping that you could tell us a little bit more about that.
Yes, absolutely. So what I did was we talked about supervised machine learning, right? And how if I have historical data, I can, make future predictions. And so what I did was I have a headset that can read EEG. And it's made by a company called Emotive, which is a female-founded company. Woohoo! And it was a really cool thing. And I saw a TED Talk. So the founder, Tan Lee, did a TED Talk on this headset like way back in like 2010 or something, like a really long time ago. And I saw the TED Talk and I was just like, I was just lusting after that headset so bad. I wanted it for ages. And then finally we had something where there was our team came into a small hardware budget and our manager was like, does anybody have any hardware requests? If you will build something cool and talk about it, we have this, and I'm like, bam, this is what I want. Give me this. And so I got this headset. And so I had all these ideas for like what I could do with it. But what I ended up doing was trying to solve the problem of lie detection. And it's kind of silly, but, I've heard all that, I'm not a neuroscientist and I don't claim to be. But I did, I did have a master's degree in artificial intelligence, and I took like 1 or 2 brain science classes when I was in college. And I'd heard all the same, like the things that you may have heard too, that polygraphs aren't that accurate, and some people don't even trust them in a court of law anymore, and some people do, but there's all this like controversy over polygraphs and whether they're that accurate. And from what little I learned from, my brain science class, one of the things I did know was that when you're telling the truth, that activates the recall centers in your brain. And when you're lying, that typically activates the creative centers in your
Makes
brain.
sense.
So I started thinking, okay, if I have this headset that's reading from these, it actually reads from 14 different points on the scalp. If I had that information, like, could I be able to distinguish between truth and a lie? It seems like you maybe could, right? Mm-hmm. So I did, my first guinea pig for this work was my husband, my poor sainted husband. So I put it on him.
Was he sweating or?
I know, yeah, seriously. Do you have an Ashley Madison account? Tell me. But he was a great sport about it. And I put it on him and I asked him a series of questions that I did know, like the correct answers to, yes or no type questions. And I was collecting his EEG data through all of this. And so I had him tell me the truth, and then I made him lie to me. And so what that gave me is a labeled data set of here's, EEG signals, and these correspond to truth. Truth would be my label. Truth or lie are the 2 labels, the things I'm trying to predict. And then I had all this data for here's what his brainwaves look like when he's telling the truth, and then here's what they look like when he's lying. And so from that, you can just feed it into a machine learning algorithm and build a classifier to perform lie detection.
You're just like, and then I just feed it in.
Yeah, it's
like,
from there.
I can't believe I'm the only one that's doing this.
Well, I actually looked. I like as a good little former grad student. It's like someone's always already done something. And I did find some research that was out there on this thing called the P300 ERP. And ERP stands for event related potential, and it's a different way to process EEG that kind of filters out a little bit more of the noise. And I guess that there have been some government agencies and such that are doing a little bit of work around this. But instead of asking questions like I was doing, I was kind of like trying to duplicate like a polygraph type experience where I was asking questions and getting answers. What they did is that this P300 ERP is essentially it's a little dip. You can see the little waveform that occurs for recognition. It basically is like a spark of recognition. And so imagine you're like walking through a crowd of people at a conference or something, and you see a face, and your brain does that. Ooh, I know that person from somewhere. Like that's the P300 ERP response. And so then what they were doing was actually using a vision-based test where they would put an EEG reader on someone and they would hold up a bunch of pictures in front of them and then see if that response happened. So you could have a whole bunch of very neutral or innocent images and then, a picture of the crime scene or a picture of the murder weapon or something like that. And so if that person had intimate knowledge of those things or had seen them before, that P300 ERP reaction would dip, or that you'd see that little waveform. And so then they could, find out those correlations. So it's just an interesting, the brain is so fascinating because there's still so much we don't know about it. So it's been really fun work. And I've been able to, present and connected with, I'll get all of these really fascinating conversations with people that come up to me afterwards who are actually, I've had some neuroscientists come up and talk to me, and it's always just a really interesting conversation where, it's so cool. And then the medical applications are neat too. When you think about all the brain related diseases that we have and folks with seizures and folks with other neurological things, people have come up to me and asked, could this help my child? If I put this on them, could we predict when an episode is going to occur or something like that? And I don't know, but like the medical ones are always any kind of health related things are the ones that always, get me. They're so, being able to use technology and machine learning to make such a tangible difference in people's lives is really
So tell me about this headset. So I looked, it looks like you can have your very own for what, $800?
Yes, mine is the $800 version.
It's actually cheaper than what I expected.
Yes, it's under $1,000.
I mean, for a mind reading device.
Yeah, it's not that expensive. And if you want to get just the headset by itself, that's I think $200 or $300 US dollars. Mm-hmm. And then if you want the headset plus the developer SDK, that is $500. And then if you want the headset plus the developer SDK plus access to all of the raw EEG data, and that's what I wanted, that was $800.
Okay.
So I have the $800 version, but again, it's less than $1,000, which is pretty impressive.
So
and I actually read a paper. Oh, sorry, go ahead.
I was just going to say, it looks like, so does it have a dongle and it's Bluetooth then? You can use either one?
It's a dongle. Yeah, I don't think it's I thought they were using kind of their own proprietary.
Yeah, it says proprietary
format.
wireless.
It's not quite Bluetooth, but it's basically like Bluetooth, but I think it's their own proprietary wireless
it says that
format,
there's both.
I think.
So it looks like you can just use regular Bluetooth as well.
Yeah. So I've used it presenting. I have had issues a couple times, like if I'm presenting on a big stage with a ton of equipment and stuff, and you know how Bluetooth can sometimes go a little fritzy when you have just a ton of signal from everywhere around. But for the most part, it's been a very reliable. I've actually been impressed with how reliable it has been and how well it's worked. And it's a really cool device. And I actually read something. I was reading some papers and stuff on the various EEG devices, and that one is supposed to be one of the best in terms of value, meaning the quality of the signal versus how much you pay for it. That ratio, it was one of the strongest. There's other ones out there that I haven't tried, so I can't give honest feedback on them, but I think NeuroSky and Muse, and there's some other things out there, but I've been really happy with the Emotive one. They have another one too, actually. Okay. I have the Epoch Plus. I saw there was a simpler one. So how clean is the data coming off of that? Because I've worked with accelerometers, and, they're reporting data 200 times per second. And it's, when you move your arm, the accelerometer data is just all over the place. So what does the data of this look like? I mean, is it the same thing where it's kind of flying all around and it's hard to interpret, using vision? Yeah, so EEG is very messy data as well. Okay. Yes, and it's really interesting because one of the things, if you look at the developer SDK, one of the things they do is they actually have events for left blink and right blink and smiling and other things. So you can actually pick up facial movements as well. And so if you actually go "Rawr" and make all kinds of crazy facial expressions and touch or scratch your face while it's doing, you will see spikes in the data.
Your husband walks in,
even
just
touching your face,
hitting yourself and messing with your
yeah.
Sorry, I'm working.
Absolutely. Yeah, no, seriously, it does. I've done that live at giving the talk. I've been look, see all the crazy stuff that happens. So it's very noisy data because just facial movement will create additional waves. So when I was doing the initial work with my husband, I had to kind of arrange the experiment to try to mitigate some of that. I had him sitting where I made him close his eyes, and that was for two reasons. Number one, and I didn't want him touching his face or anything. I made him, don't touch your face or anything. You just have to, very calm.
So you handcuffed him, made him close his eyes.
Yep.
And then made him lie to you.
But when you do that, that will affect the data. I just wanted
Okay.
really clean data for the initial, experiments and to build a training set. And so when I did that, I collected it and was able to get that. And then also because I didn't want him reading the questions like over my shoulder, because I was asking him a series of questions. And I was also annotating the data at the same time so that when I would start to ask a question, he would reply. I was trying to, there's all this data that's being taken continuously, and I wanted to just be able to slice out, here's exactly where he's processing and thinking about the answer to that question. And so I used that information too. And if he was able to read the questions over my shoulder, I wouldn't have been able to, pinpoint as exactly like when he was thinking about his response. So
I saw one of these devices at like CES, and I think it might have been around like 2010 or maybe a couple of years after that.
Okay.
But like they had it hooked up, and they were trying to get people to like change channels on a TV. Like is it pretty like, is it reliable for doing something like that where you can sort of think of a certain thing or in a certain way and send out a signal reliably?
Yeah, great question. The answer is if it's a binary signal, that's easier, much, much easier to do. I have a demo that I will do on stage and that I'm comfortable doing on stage because I can do it fairly reliably. And that is making a cube move with your mind.
Okay.
And it's a really cool, it's very visually exciting. And that was actually what they did during the TED Talk that made me be like, oh, I need to buy one of these right now because I need to be Jean Grey before I die and move something with my mind at least once to have a complete and fulfilled life. So when I did this, I find that if it's just a binary thing, so either you're not making the cube pull or you are making the cube pull, it's pretty easy to force your mind into distinct states. So when they when you're training the cube to do this, it actually brings up a little thing and have you just record your brain at rest, because our brains all have unique signatures, much like we all have unique fingerprints. Everyone's brain has a unique signature,
like
and so
a noise profile.
Exactly. So that way you kind of, it records your brain at rest for a second to kind of get that neutral base state. And I always just kind of try to go zen and go to my happy place and just completely relax during that point. And then you record something, your brain thinking something during the pull. So there's another 8-second record time. And so in your mind, you could be thinking, I always think pull, or one long pull, like when I'm doing that.
Yeah.
But it doesn't have to be the word pull. You could be thinking hamster dance, but as long as you think the same thing consistently, when you want that cube to pull, it should work because it's just pattern matching, right?
Yeah.
And so I will train it to, and I usually try to get into a very excited state where I'm thinking pull with, high energy kind of thing, so that it's a very distinct on-off thing. And that way, then I just, force myself into an excited state, and then that will make the cube pull, and then I can make it stop just by relaxing my mind a little bit. But when you're trying to do additional things, because I've tried training it on more advanced things where let me try to make it pull and turn and rotate or go back, and to do that is a lot more difficult because you have to be able to force your mind reliably into 3-4 different distinct states, right? And that can be hard just to control your thoughts.
Well, especially while you're on stage, like, talk about noise then in your brain.
That's
going back to your lie detecting piece though, considering that you were trying to compare it to a polygraph, did you have, get any kind of numbers comparing your accuracy to a average polygraph accuracy?
Yes, I did look up those numbers. So I think the average polygraph accuracy, a number that I read for that was 65%, which sounds fairly low. And and again, I have the source written down somewhere, but it's everyone says such different varying things about polygraphs.
Yeah, how do you test it? 'Cause
it's hard to know what to trust, right?
Yeah, exactly.
Kind of like food. I feel the same way about anything food. It's like everything is, this is bad for you. Oh, this is good for you. And I don't know. But with polygraphs too, so 65% is one number that I've heard. And my algorithm, so some of the initial stuff with my husband were basically all I was trying to do was differentiate between his truth data and his lie data. It wasn't like a thing. But I got fairly good numbers on that one. And then what I'm trying to do now is to make it generalize and work on anyone. Because right now, like I've actually done it on my manager as well. And I was so lucky because our team actually had an offsite. And so we were all meeting together. And this was the year when we had a Channel 9 video requirement. So we had to produce a certain number of Channel 9 videos a year. And so our marketing team had actually bought a camera crew to our offsite. So there's all these camera guys around, like just in case anybody felt like recording a video to help us with this metric. And so I was like, oh, it would be fun. And I like grabbed a cameraman and I grabbed my manager and I was like, remember that expensive piece of hardware that you let me buy? Well, I've been doing something with it. Would you mind if I just recorded, asked you some questions wearing this and recorded it? And he was like, yeah, sure. That sounds whatever. And so, oh my gosh, it ended up being so funny because I put the headset on him and asked him a bunch of questions. And I asked him a whole bunch of like truth, and telling him to tell me the truth, and then had him lie to me to get again that training data, so that I understood what his brain looked like when he was telling the truth and what it looked like when he was lying. And then I asked him a bunch of just like silly questions around, is Microsoft the best company in the world to work for? And am I going to get a promotion this year?
Yeah.
And that sort of thing. And so it was just very funny, and it just his responses were very funny as well. So just having it captured on camera was just priceless. So.
Yeah. So that actually brings up a good point. So you, so in your software then, so you built it so that you could train it on the fly then as well?
Yeah, so what I'm doing right now, it's a bit of a manual process.
Okay.
So I have to and part of it is the tool. So I'm collecting it using a tool made by Emotive called TestBench, and then they have a tool. They actually store the data in a proprietary format, but then they have a converter inside of TestBench that converts it to CSV, and then Azure Machine Learning supports CSV just fine. So I was using the Azure Machine Learning Studio to do this work, and so what I did is I have to actually take the data and then run that converter real quick and then do it. So I don't have like a real-time end-to-end system where I could just put it on you live right now and then ask questions and get the response in real time, just because there is that one manual step. And I've actually been going back and forth with Emotive support on this because they said that, hey, there's this thing and that it was a command line thing. But I think they ended up baking it into the tool and there's not a command line version of that converter. And I keep asking, can I please have that? Because then I could have this be a real time, like fun thing.
Yeah. You could just hit train and then hit some buttons while they're talking.
Right. Yeah. So the training, but that's the thing is I don't want to have to train it individually on each person. Like my goal would be, is there a way to normalize the data across all people so that maybe I could do maybe a really quick training or something to get that baseline, just like I did with the Emotive other thing, and then be able to use an existing model to be able to figure that out. Because it's almost like this, when you think about it in the core, it's a lot like speech recognition, right? Like all of us have different voices with different pitches and timbres or whatever the vocal terms are, but we still are saying the same words, and a speech recognition program can pick up, even though we have different voices, it can pick up on those things because it's been normalized, that data's been normalized across a variety of different people. And it's really the same thing with brainwaves, because it's the same thing. It's time series, waveform type data, and I'm getting it from these 14 different channels on the brain. But then if I can take that and normalize it across different people and different brains, then I should be able to use one classifier to detect, general purpose lie detection on anyone, and that would be really cool.
Yeah. But are the brain areas the same in every person? I mean, I've seen like the classic maps where it says, this is here, this is here.
This is responsible for this.
I wasn't sure how consistent that was.
Yeah. So my understanding is that, the basic things like speech processing and, your long-term memory and storage and stuff are all that is consistent across people. But there are just different, the noise comes in with just kind of what the waveforms look like and what your brain at rest looks like and that sort of thing.
Well, and then if you find like a psychopath, it'll be different.
Yeah, that very well could be. I have not done any psychopath.
Because like their heart rate tends to be like
I can lend you Jason for a little
and they're not very
Thank
excitable.
you.
I don't know what that's like.
Yeah.
Oh, I'm very excitable. What are some other cool ML projects that you've worked on as well? Because I mean, this is just one of many.
Yeah. Oh my gosh, there's so much cool stuff out there, honestly.
Yeah.
So there's a lot of things with a lot of projects lately that I've seen around product placement on shelves. That one of my colleagues did some work on this like last year.
Okay.
And do you know Ari Bernstein? Do you know him?
No.
He's okay. All right.
Okay.
He's on our extended team.
Okay.
But he's done something, and I've done similar work in that area where essentially there are these companies, and let's say that they are looking to do correlations, or so distributors sell things to a large group. So imagine you are, any kind of person that, sells something, and then it actually is sold at the front end by like a grocery store or something like that. And different makers of food and such pay for different kinds of product placement, right? Because to actually display something at eye level in a grocery store costs a lot more than to display, have it stuck on like the very bottom shelf or the very top
in
shelf
the back
where
corner.
it's harder for people to see. Yeah, exactly. But that is something that in those negotiations actually happens between the distributors and the actual manufacturers of the food. And so there are auditors that go around and actually take pictures of the various grocery store shelves, and then have to then manually audit and see, okay, is everything, where it's supposed to be according to this contract? And so using machine learning to do that, that's a really interesting computer vision task, where inside of computer vision, there's something called object detection. And object detection is trying to recognize something within an image, right? So if there was a huge picture of me walking a dog with a Ferris wheel in the background and all this other stuff, and you wanted to recognize dogs, like it would just be able to pick out, do a little like square bounding box around just the dog, right, in that whole big busy image. And so that's something called object detection. So being able to recognize like the food within the image and then where it is relative.
Is it hot dog?
Shelves.
Is a good example of that.
Yeah, hot dog, not a hot dog. Oh,
yeah, hot dog or not? That's
fast,
what's going.
Yeah, hot dog or not a hot dog. Yeah.
Why didn't we think of that?
That was a different problem though, because the hot dog, not a hot dog thing. For those of you who don't know the backstory, that was a really funny episode of Silicon Valley, and you should definitely watch the show Silicon Valley because it's fabulous. But what they were doing there was actually a classification problem. It wasn't an object detection problem, because he was taking a picture, and the hot dog or whatever piece of food it was the main subject of the screen, and so that's classification, trying to figure out, okay, this is either a hot dog or, if he had done it well, hot dog or a piece of pizza or whatever other kind of food. But in this particular case, object detection is actually trying to recognize like a sub piece of the image is something.
And it's a real app too, by the way.
Yeah, isn't that funny? Someone
and I found my kids, they were obsessed for a while. So they were first they were making me do it, and then I told them to just get the app and do it. So they were checking everything, whether or not it was hot dog. And what's interesting, I basically figured out, it's basically just going off of the amount of the colors that are in the image. So if you have something that's like brown, yellow, and red in the right proportions, it would say, yes, that's a hot dog.
Oh, that's funny.
Yeah.
Did you use fake hot dogs? Like, what kind of test data did you use?
They would take pictures like random items, like a chip bag or something.
Okay.
One obvious one to trick it is to like take a picture of like a brat.
Okay. Yeah.
It's like it would say that it is. But if you had like a hot dog with like with no bun and no ketchup and mustard, I think it would say that it wasn't. Depending on the circumstances, obviously. But then if you took, I don't remember how we had some consistent way of fooling it. Where it was like a chip bag or something that had just the right proportions of those colors. And it would say, oh yeah, that's a hot dog. And it looked nothing like a hot dog.
Oh, that's interesting. Yeah. A lot of times things like shape and such can factor into.
Aspose offers a powerful set of file management APIs with which developers can create applications, which can create, open, edit, and save the majority of popular business file formats. Their product range supports a multitude of file formats, including Word documents, Excel spreadsheets, PowerPoint presentations, PDF documents, OneNote, Outlook, Project, Visio files, popular image formats, and many others. Aspose produces APIs for .NET, Java, and the cloud, which can be utilized in almost any modern language available today. Visit aspose.com for a free 30-day no limitations trial, and if you get stuck, message the friendly support team for help. All technical support is offered free of charge. And remember, if you are a lucky winner, you will receive a free developer small business license for Aspose.net, a powerful toolkit for working with Word documents in your applications.
One of the things that's really a challenge in the machine learning community is just when you're using neural nets and kind of that deep learning factors, the explainability is really difficult. Like what features or what are the things that are actually making the impact on getting those results. They actually, a really funny example is someone actually created a neural net to be able to distinguish between dogs and wolves. And it was actually very, very accurate. The accuracy numbers were great, and it was doing a great job figuring out, okay, this is a dog and this is a wolf. And then someone went and tried to, figure out, what it was that was actually causing that. And they found that it turned out that whenever there was snow in the background,
As I say, yeah,
it was a wolf, right? And it was just like the pictures that they used just happened to show that. And so it was always, and it turned out just being the snow. It wasn't actually using anything about the animal itself, but that was the most telling factor in that particular thing. So it's a good thing to remember when you are doing machine learning, just having the right kind of data can make such a big difference. I know we have our custom vision service now too, which is awesome because you can feed in your own data and it does classification, like being able to figure out, if you had an assembly line, for example, and you wanted to use computer vision to automatically detect, which part is coming down the line or something and potentially do something different with different parts. You could train it to recognize, this is, part A versus part B versus part C. And that's, a really cool example of using the training. But I always tell people when you're getting training data, make sure you're doing things like using diverse backgrounds. So for example, if I was trying to build a dog versus cat classifier and I had all my dogs with a red background and all my cats with a blue background, then again, it could automatically just actually build a red versus blue classifier as opposed to that. So you have to think about, different lighting conditions, different things.
It's almost like it's lazy. Think of it as it's looking for the laziest way to solve that problem.
Right, which is good. That's what it should be doing.
Right.
I think that's wonderful.
Yeah, exactly.
Find the fastest, easiest, simplest way to differentiate between two things. But when you think about it, that's how we do it as humans, right? You have this series of like images in your head. Like one of the things that the cognitive services does is predict age. You give it a picture of a face and it will tell you, how old it is. And when you think about that, it's processing it the same way that humans do, where you have this mental model in your head over time where you learn various, people and faces and you know their age or their approximate age. And so you build this mapping in your head of, okay, this face is about this old and this face is about that old. And that's really what a machine learning model is doing too, is it has all this historical training data, all these faces with ages mapped to them, and then it's able to build a model as well, saying, okay, now for a new face I've never seen before, based on what I've learned, here's what I think that is, or how old I think that person is.
Yeah, that actually,
it's fascinating stuff.
Yeah, that's a good lead into my next question, which is around accuracy.
Great.
So, I mean, there's a whole bunch of questions I have around accuracy because, like you were just talking about, visually determining how old somebody is, and like I know that like my accuracy is very low.
Yeah, mine too.
And the so the computer, I mean, I always, anytime I've done anything with machine learning, it's like, hey, we have this data that we're using to train, and maybe we have 1,000 records, we have 1,000 faces, and we have the ages. And then what's interesting is whenever you go to test it, like you throw one more image at it, but it seems kind of weird to me because doesn't the training set of 1,000 kind of, you can figure out the accuracy from that, right? Or like, how does that work? Whenever you throw like the one after the 1,000, like what does that do?
Yeah. So typically if you're going to train, based on like kind of the law of large numbers, like assuming you have a ton of data and such, a typical like kind of industry standard for the split would be to use 70% of your labeled data set for the training and then test with 30% of your data. So it shouldn't be just like 1,000 images and then test with one and then boom, there's my accuracy number. You should, like if you have a data set, you use like typically 70% for training. So you do use the majority.
Use like a
or you use
30%.
Yeah, and that works if you have the law of large numbers and you can assume that it's like a random distribution. If you don't, a lot of times there's something else called k-fold cross validation. And so you choose some k. So let's say k is 10. And then I would take my whole labeled data set and split it up into 10 chunks. And then I would build a model with 9 of the 10 chunks and then use the remaining one to test, and then I would build another model with a different 9 chunks, and then use the 10th to check, and then repeat that like 10 times. So you're doing, you keep validating, and then you can kind of find the best model and the best distribution of the data based on that technique. So that's another thing that people have done. But your overall question is really good. Like, how do you know like what accuracy is good enough and that sort of thing? And that's a hard question. And it really, the answer is unfortunately the horrible architect's answer of it depends. It really does depend on the problem you're trying to solve. Because if it's something like I'm trying to predict whether this person will click on an ad or not, whatever. If you can predict it right 75% of the time, great. You're doing, you're probably doing better than whatever. It's not one of those things. But one of the first job opportunities I got when I was first graduating from school, I was deciding between a number of different companies, but the 2 top ones for me were Microsoft, which I ended up taking, and then working for MIT Lincoln Laboratories. And the problem they wanted me to solve was around anti-ballistic missiles. So I don't know I did not know anything about this, so here's my understanding of the problem. But people, sometimes use ballistic missiles and try to fire missiles at us. And there is something called an anti-ballistic missile, and what it does is it goes and it blows up the missile before it hits us. But what can happen in a warfare situation is that sometimes companies, it's really, an actual missile is expensive, but you can fire dummy missiles that actually don't have a payload in front at a country. And then if you use anti-ballistic missiles, you're using up very expensive anti-ballistic missiles that can choose these to blow up essentially what would be duds, like not real missiles that are coming at you. And so what they wanted me to do was use my machine learning background to build an algorithm to figure out if a missile is coming towards you, figure out whether it is a real missile or a fake missile, and then only fire the anti-ballistic missile if it is a real missile. And that's something where you need a very, very high accuracy if you are going to be happy.
No pressure.
If you are wrong, people die, right? Yeah. And same thing with some of these medical situations. If you're creating an algorithm to predict whether or not someone has developed cancer, you need to be very accurate. Yeah. So it's really an it depends question based on the different how it's going to be used.
Mm-hmm. Yeah, I don't know how much I want to drill into more accuracy questions, but like one that I hear all the time, I always hear like, oh, this algorithm for detecting spam is more accurate than humans. Like when somebody makes that claim, like what does that actually mean? And because how would we know?
Yeah. So I'm guessing what they did is just surveyed a whole bunch of humans and then developed an average rate or something like that.
So here's your average human, which is probably depressing.
So,
okay.
Yeah, maybe. I know we did a similar thing because Microsoft actually just beat, it was very exciting. XD and his team actually beat the human transcriber error rate.
Right.
This was really, really cool in terms of speech recognition. And this is a goal a lot of companies have been working at for a long time. So I believe a professionally trained human transcriber who is listening to stuff and transcribing it has a word error rate of approximately 5.6%, I believe it was. Jeez. And so that's been like the golden standard is, can we get an algorithm that is better than 5.6% word error rate? Because that would beat human transcription, the very best human transcribers. And actually, I think it was like December of last year or something, XD and his team actually did it and were able to beat the human transcribing rate, word error rate for the very first time. So it was really exciting stuff to see that. But I assume that was calculated, with a fair, hopefully statistically large enough sample size of human transcribers, and then seeing what their the average word error rate was for them.
That's very cool. So
yeah.
Oh, go ahead.
I have a question. So now that we're kind of like all jazzed up on machine learning, we're all excited. We want to do it everywhere, right? What is the hello world of machine learning? What does that look like, and how can I get started?
Goodness. I can tell you exactly what it looks like. It looks like irises, my friend. It looks like irises. So there's it's a kind of a joke in the machine learning community. There's a couple of very famous data sets that are used schools and training and such that like everybody is very familiar with. One of them is the MNIST handwritten digits set. And so it's a collection of a whole bunch of things. Like think of the post office and how when they're processing mail that has all these handwritten like zip codes on them, how do they distinguish, where that should be routed? And so being able to recognize a handwritten digit, like an image essentially of a 0 or 1 or 2, and be able to map that to a digital understanding that is a 1 or a 2 or whatever. And so there's a very famous data set of all these handwritten numbers. And so that is one thing that's used very commonly as a Hello World type exercise. And then another one is there's a very famous iris data set, and iris is a kind of flower. And so you can distinguish between, I think it's 3 different types of irises based on the length of the petal and the width of the petal and several other features of what the flower looks like. And so those are oftentimes used as data in the very Hello World examples of, okay, let's take this famous data set and see if I can predict which number this new handwritten digit is, or which kind of iris this is based on this information. And so there's a whole bunch of great online resources you can use. Coursera, the online massively online curriculum that was created by Andrew Ning and his team is one really good resource. They actually founded that company with Andrew Ning's machine learning course, and he's a professor at Stanford, and he does a great job of explaining machine learning kind of end to end. And so that's a great thing if you want to kind of learn all of the math behind it and that sort of thing. Andrew Ning's Coursera course, and I think he's also doing deeplearning.ai now as well. And he explains things in a very easy to understand way. So that's one great resource. Another resource, if you learn by doing, is Kaggle. I love Kaggle. So it's Kaggle, Kaggle, Kaggle. Okay. And what Kaggle does is if you want to practice machine learning, you really need 2 things, right? You need a cool problem to solve, and you need data to solve it with. And the thing that's amazing about Kaggle is it gives you both. Like it gives you, here's all these really interesting problems, and it's a competition. They have a competition site. So basically, companies can actually pay to put their stuff up there and essentially crowdsource out some of their hard machine learning problems. Yeah. It's really cool. And there's cash prizes. Like I know Yelp has done some, and Microsoft has done it, and Google, and Netflix recommendation stuff. So there's all these really cool data science machine learning problems that get put up there, and then you can go and they give you the data, so you just can download this data. There's actually one with the TSA right now, which is kind of interesting. Like TSA help us, fight terrorism better, and there's a TSA data set in there, which is a little kind of scary. But like you can get access to all these really cool data sets, and then just practice machine learning with them and see how well can you do. And there's a leaderboard, so you can submit your work and see how well you stack up against other people. So I highly recommend Kaggle because it's a great way to just like get started, and it's a very supportive community. There's like forums and stuff where people can ask questions and that sort of thing. So that's really wonderful in terms of getting started learn by doing, because that's how I learn best anyway. I need to actually write some code and then be like, okay, I think I get this now, right?
Exactly.
It internalizes it better. Those are 2 resources. And then of course, Microsoft has a number of really good resources. We have a data science certification now. So there's an actual like certification that you can get from Microsoft around data science. And then there's a whole bunch of great tools that we have. And what I love about Microsoft is that there's so many, we can kind of meet you wherever you're at on your machine learning journey. There's the cognitive services, which is if you just want to kind of consume machine learning stuff and you don't actually want to build it yourself, there's the cognitive services. And those have taken common artificial intelligence type problems like facial detection and speech, common speech things, speech to text and text to speech, and speaker recognition, and emotion detection, and computer vision. Given this image, tell me what it is, and various types of natural language processing, and text analytics, finding the sentiment of text, extracting out the key phrases, like all of those kind of things that people want to do over and over and over again. And they've built those services for you, and then you just basically call a REST endpoint, so you can do it from any language, any platform, super easy, and then just use it. So that's one thing if you want to, just use that. And then we also have the Azure Machine Learning Studio, which is what I used for the EEG project. And that's, a browser-based thing where you can drag and drop in, 25 different machine learning algorithms and utilize those. And then we also have kind of the new wave of machine learning projects that kind of add on to that, which are what was codenamed Project Vienna, are the Azure Machine Learning Workbench, as well as the Visual Studio tools for AI, and then 2 new services inside of Azure, which are the experimentation service and the model management service. And those are really great resources too, that if you're already doing a lot of Python work and stuff like that, you can roll your stuff into those and use the same frameworks and stuff that you're already comfortable using. And it makes it really easy to deploy. Like you can basically take the models that you build and package them up into Docker containers, and then either, do your training on GPUs or locally, and just kind of a mix of different deployment options and all kinds of stuff. So that's a really great tool to have in your tool belt as well. And then finally, we also have an open source deep learning framework. So if you want to do it's very similar to Google's TensorFlow, which is open sourced. We have the Cognitive Toolkit, or formerly called the CNTK, which is also open sourced, so you can contribute to it if you want. But that's a great thing for if you want to do it's specific to deep learning. So if you want to solve a deep learning problem, you need a lot of data to do it, but it's a really good way to experiment with that, and it's open source and free for anyone to use. So it's so many options, and all of them have different tutorials and stuff like that based on kind of.
That's what I was going to ask you about, because I found, it seems to be like while the stuff has gotten more complex and like the thinking in the field has progressed, also the tools that make it easy for beginners or people that just don't really know how to do machine learning. Like, I've been able to use the Cognitive Services API. I was in a hack recently where, they were doing like a live video call type of thing. And they said, hey, we want to analyze the emotion of the people that are in this call. And I don't know, it was like an hour and a half of work, and I hadn't touched any of it before.
Yeah, and it's done.
Yeah, I was basically taking screenshots, sending them in there, and then it would give me back, this JSON document that had the emotion data, and it was really cool. It's so easy to get started now, which is really cool.
That is awesome.
Very cool. Okay, let's move on to the pick of the week, which is use Azure DNS service to provide Azure DNS to provide custom domain settings for Azure services. So basically, for Azure Functions, for IoT Hub, for a whole bunch of the different services, now you can actually use custom DNS records, which is really nice because you basically get to use like a vanity URL on these. So you can, they use the Contoso example, where you can basically have, contoso.com addresses assigned to all of your different services. So if somebody starts poking around your stuff or monitoring traffic or whatever, they'll actually see your domain names on there instead of the sort of generic Azure names. The other nice thing about this is that you are, if you're using IoT Hub, for example, and you're sending data into there, some people like to have these warm and fuzzy response, or these warm and fuzzies that, the place that they're sending their data can be, they have control over it and they can swap it out if they need to, if they're not happy with the service or whatever. So a lot of people were asking for this, and it's great to see this implemented in here now. And then Jennifer, we play a game on this show. It's for kids, but we like to play it here. So why don't you pick a number between 1 and 4 inclusive, and let me know what it is.
Okay, got it. You want it now?
Yeah.
3.
3. Let's see. Everybody picks 3. I'm almost out of 3s. I might be out of 3s. Do you have a second choice? I might have to.
2.
I might have to remove 3. Okay, so 2 here. That was taken. Man, I'm really running out. Okay, hold on. Here we go. Would you rather turn into a fly or turn into a cockroach?
So I don't know the average life expectancy of a cockroach. I know flies only live for like 2 days or something, right? And then they die, I feel like. Isn't that true?
I think that's like a myth.
I think they have a really short life.
Yeah. Well, here, let me.
So I'm not sure. And cockroaches, do they like? I'm not sure if I understand the life experience. Then again, do I want life as a cockroach? Is another thing.
Yeah.
What's the
so they got the nuclear thing. Really? So if
yeah,
there's
that's
war,
true.
you got a good chance of living.
You could survive anything. You can live in New York, in my sister's apartment very easily. But the other thing is, if you were a fly, you could fly, and cockroaches can't fly.
Yeah. So flies generally live for 15 to 25 days. 15 to 25.
Okay, I was wrong.
And cockroaches live up to a year.
Live up to a year. Okay. So I would have a longer life as a cockroach, but I would be able to fly as a fly.
Yeah, you could go wherever.
Yeah, I could travel.
And you probably don't have cockroaches where you live, right? So like,
No, I don't. We
you
don't have
would,
cockroaches
you'd
here.
stick out like a sore thumb.
So that means if you're
quite
a
true.
cockroach, you live in a nice area, that nice temperate climate too.
Oh, is that how this works?
Is it?
No,
Yeah,
because
we
you
have
turn
flies.
into it though, Carl.
Well,
So you're like,
Yeah.
you're just minding your own business, and then
so if you
Boom.
turn into it in the middle of January, that might suck.
I know I was thinking that too.
That's true. That's true.
Well, it sucks either way.
There's not a lot of like options. First of all, I'm really glad I'm a human, and I would like to take that choice first, please. If I get a choice, but if I have to choose between one of those
It's not
two,
a choice.
I think I don't know.
Well-
I would say cockroach just because it's a longer life and more resilient and that sort of thing. So I was originally thinking cockroach, but just the ability to fly would be really cool. So
Yeah.
like fly is really compelling too.
And you could,
even
if it's winter, you could
Yeah.
go outside and like freeze yourself and then come back in the summer. That's an option.
that is an option.
That does work.
I'd have to be a maggot, right? Aren't
Yeah.
they? Don't they start as little maggots? Oh, yeah.
Yeah, a friend of mine, he would like freeze flies and they would be frozen, and then he'd take them out and they'd be fine. So I'm just
Wow,
saying.
Isn't that crazy? Yeah. Okay. Well, then I'm glad we have a plan, guys. Let's do this thing.
Okay.
We're ready.
Let's execute this. Wait, no, let's not. Okay, perfect. And Carl, pick a number.
I'll take the next available one since
Next
we're
available.
running low.
I'll take the previous available one here. Would you rather place first in the Olympics and have the gold medal taken away from you 1 year later, or win second place but you get to keep your medal forever?
Nobody remembers the guy who came in second and then got it later.
Well, that's why you have the medal.
I'd rather have it. You have the notoriety. I mean, that's why you do that. Not
Wait, so which one are you picking? The gold?
the gold that
Well, yeah.
gets taken away.
Yeah, exactly.
But I'm assuming you did something very, very bad to get it taken away, though.
No, they just came in your house and just took it. No, you have photos.
Okay.
No, I
It
don't.
wasn't like
I don't
he
know.
had all this
No.
notoriety.
The
For,
card
like,
doesn't say.
doing
I'm just
horrible
making this up. I have no idea.
Okay. As
I
long
know,
as
there's
you don't
more-
have to like
more questions
do
than
something
answers.
bad to get your first place medal like taken away.
Yeah, like, oh, geez, yeah, it turns out you were on drugs or something.
Yeah, exactly.
Yeah, what do they call that when they with the blood? That's like everybody does
Blood
it.
testing.
No,
Doping?
doping. Yeah.
Yeah. Well, they've been taking like away Olympic medals like going back like 15 years now.
Yeah.
So I mean, you can get one taken away from like 15 years ago because of like they redo the blood test. So that's interesting question.
Okay.
Kept the blood for 15 years of former
Yeah.
Olympic athletes. Wow, I didn't realize that.
Okay. Anyway, so Jennifer, where?
On that note,
Yeah, where?
Great show, guys.
Yeah, we're gonna keep your blood on file. But for anybody who wants more information about you, non-blood related, where can people find you?
I do have a blog, and I'm on Twitter and LinkedIn. I'm gonna have to check out this new resume creating function. But my Twitter is Jennifer Marsman, all one word, and then my blog is blogs.msdn.microsoft.com/Jennifer.
Which is awesome. Okay, and Carl, where can people find you?
You can find me on Twitter at Carl Schweitzer.
You can find me on Twitter at twitter.com/ytechie. So Jennifer, thank you so much for coming on here and talking about some really awesome machine learning scenarios.
Thank you for having me.